Hello and welcome back. We are going to start a new unit now called 2D kinematics. And this unit is going to be broken down into three parts. The first one is going to be a trig review piece, and then a small unit on vector addition, and then we'll be getting into projectile motion. In this video, we're going to do the quick trig review. Now I know most of you are pretty well versed in trig by now, but I want to make sure that we have a common background and that you also can see what sort of trig is going to be used in our class. So as I continue through the notes, you can fill them in on the corresponding notes handout. All right, the first thing is the definition of trigonometry. Trigonometry is the study of the relationships between the sides and angles of triangles. And we're going to be very careful to make sure that we label our triangles correctly. So the first thing is all of our angles are going to have capital letters, and then opposite those angles will be the corresponding sides, and they will have lowercase letters. And we will always label the right angle as angle C. Also in physics, we will always be in degree mode in our calculator. All right, two relationships that you can use with all triangles are the law of sines and the law of cosines. Let's look at the law of cosines, or the cosine law. The cosine law can be written three different ways, but basically you're looking for a side. You have to know the other two sides, and you have to know, if you're looking for side C, you have to know angle C. If you're looking for side B, you have to know angle B. But because of the way we're going to label our pictures in physics, we will always use this version of the cosine law. So that'll make it a little bit easier for us. All right, let's do a quick practice. So here we have a triangle, and we are going to be solving for side C. You can see we do know angle C, and we know the other sides. So pick the first version of the cosine law. Take a second, plug in your values, and see if you can get the correct answer out of your calculator. I'm really testing more of your keystroking than we are plugging the numbers in the cosine law. So pause the video, do a quick calculation, and when you're ready to resume, hit play again. All right, so how did you do? So I wrote down the cosine law here. I plugged in my numbers. Did you get 6.67 out of your calculator? If you did, whatever you're doing is perfectly fine. If not, try again, ask a friend, or come talk to me, because we want to make sure that you can get this number out of your calculator. All right, next let's look at the sine law. The sine law is a relationship between a side and the sine of the angle, the respective angle. Side B, the sine of angle B, or side C and the sine of angle C. It's really just a ratio proportion relationship, and I only need to know two things. If I know A and B stuff, I'll use this. If I know B and C stuff, I'll use this. But because it is a ratio and proportion relationship, you could actually write this ratio upside down. And so you can use whatever version of the sine law that you're used to or that works for you. Let's practice the sine law. So we have the same triangle here, but in the previous cosine law example, we did find side C. So I wrote that in here as 6.67. So we are trying to find angle A in the triangle. So I know side A, angle A. I know side C and angle C, so I think I should use A stuff and C stuff when I set up my sine law. Let's pause the video again, see if you can work through this example. All right, look at my solution. It's going a little bit off the screen here, I see. But I set up my A stuff and my C stuff, plugged in my stuff, I then cross multiplied, so you can see I took 8 times sine of 37 equals sine of A times 6.67. And then I divided both sides by 6.67. And sine of A equals 0.72. This is where some people get stuck. In order to figure out what plane A is, what angle A is, you have to take the inverse sine of both sides. Taking the inverse sine of this will get rid of the sine, and then the inverse sine of 0.72 is where I get my angle of 46.2 degrees. So practice that also. All right, the next thing, we're going to talk about Pythagorean theorem. I know you know what it is, but let's look carefully at where it comes from. So let's say I had a triangle, and maybe I didn't know this triangle was special, but I did know that angle C was 90 degrees. So I'm going to use the cosine law on this. If this is an angle of 90 degrees, I'm going to solve for this side because you can see I know my other two sides, but I don't know this side. So I'm looking for side C. I do know A squared and B squared. That would be my A squared and my B squared. And when I put in my angle here, since my angle is 90 degrees, the cosine of 90 degrees is 0. So this shows me that if I have a right triangle, if I have an angle C that is 90 degrees, the cosine law is going to simplify into Pythagorean theorem. So that's a reminder to me that I can only use Pythagorean theorem when I have a right triangle, because this only works when I had plugged in a cosine of 90 degrees. So these next relationships can only be used with right triangles. You can use sine law and cosine law with right triangles if you want, but it's a lot of extra work. So these are like the shortcuts you can use for right triangles. So obviously, you know you can use Pythagorean theorem, but you can also use sine, cosine, and tangent relationships. Now, we also have, cotangent, cosecant, but you know what? We're not using any of those in physics. We only need to know these three. So get used to these three: sine, cosine, and tangent. All right, so take a second. These are right triangles. You can see they're clearly marked as right triangles, which means that this would be angle C. And use the respective sine, cosine, or tangent relationship to solve for x in this example, and then to solve for theta in this example. Hit play when you're done. All right, I used tangent for the first part, and I used sine relationship for the second one. All right, but now I want to show you how we will use these relationships in physics, a little taste of what is to come. So in this example, we're going to pretend that right here where my mouse is a soccer ball. So it says a student kicks a soccer ball 12 meters per second at a 32-degree angle. And it says we often want to know how fast the ball is traveling in the x direction and how fast the ball is traveling in the y direction. I know it's going 12 like this, but sometimes I need to know how fast it's going in just the x. And so if this is my angle, my velocity in the x direction, which is called the x component, I would say is adjacent to this. We know the hypotenuse, and so we could set up a trig relationship to find the x component of the velocity. We could also set up a trig relationship to find the velocity in the y direction, because that y direction is opposite the 32. And so those are the kinds of things, whoops, I didn't do the y direction, it looks like I only did the x one. So that's how we're going to use that in our examples. Another physics example. It says we often want to find the net result of something happening in the x and something happening in the y direction. For example, we might have a student who walks 60 meters east and then walks 41 meters north. And then we could say, what is the distance traveled? Well, that would be 60 plus 41, that's 101. But what is his displacement? Like from where he started to where he ends up, what is his displacement? Well, you can look and say, well, we could use Pythagorean theorem for that. But that's another way that we will use the trig in our class. So quite simply, simple sine law, simple cosine law, Pythagorean theorem, sine, cosine, and tangent. We just have to be really good and really fast at those relationships.